On this page, we're going to do a lot of examples with implicit differentiation so that we can kind of wrap our heads around that process and just see a lot of different examples. So I want to use implicit differentiation to find y prime for the equation y squared minus y plus 4x is equal to 0. Now, I could actually solve for y in this problem. If I really wanted to, I could. The process would not be particularly enjoyable, though. We'd actually have to use the quadratic formula, and then we'd have something like y equals, negative b plus minus square root of, here you'd have like some function of x here divided by 2a. In this case, it would just be 2. So I would actually end up with, in this case, two separate functions, because I have a positive case and a negative case, and then I have to use the chain rule when I take the derivative of the square root of whatever that inside part f of x looks like. So it's not a particularly nice way to do the problem. So it's much, much easier in this case to use implicit differentiation so that we don't have to solve for y. So my first step is I'm going to take the derivative. I'm going to take the derivative of both sides of my equation with respect to x. So when I take the derivative of y squared, I take the derivative of that using my power rule just like I would with x squared. Well, the derivative of x squared, and I can do that off to the side, the derivative of x squared is 2x. So that means that the derivative of y squared is going to be 2y. But hold on a minute. Remember, we can think about y as a function of f of x, which means here we really have a function inside of another function. We would be using the chain rule here. So we need to multiply by the derivative of the inside part, which for this problem, the inside part is y. So the derivative of y, that's just going to be y prime. So I have now in this equation so far 2y times y prime minus, let's move on to our next term, I want the derivative of y. And let's just get y here. So the derivative of x is 1. The derivative of y similarly is also 1. But again, here I have a chain rule. So I need to multiply by the derivative of the inside part, which is y. I need to multiply by y prime here. So now I've got 2y times y prime minus 1 times y prime. If we have any terms that are solely in terms of x, that are only in terms of x, we can just take the derivative of those like we've been doing all along. So the derivative of 4x with our power rule is just going to be plus 4. And then we do also need to think about the derivative of the other side of our equation. So in this case, we would need to think about the derivative of 0, but in this case, the derivative of 0 is still just 0. So if I wanted to simplify this and clean it up a little bit, I've got 2y times y prime minus y prime plus 4 is equal to 0. So my first step is always take the derivative, and I've done that here. My second step then is to solve for y prime. I'm actually going to solve for the derivative. So in a problem like this, what I'm looking for is I'm looking for all the terms that have a y prime. I want to keep those on the same side of the equation, or if they're not already, I want to get them on the same side of the equation. And then everything that does not have a y prime, which in this case is just the 4, I want to move that over to the other side of the equation. So I'm just going to start by subtracting 4 from each side. That would give me 2y times y prime minus y prime is equal to negative 4. Now if I look at this left-hand side, well, this first term, 2y y prime, that has a factor of y prime. My second term, y prime, also has a factor of y prime, so I can factor out that y prime. So I'm going to factor out y prime and then divide each of these two terms by y prime, and that would leave me with 2y minus 1 is equal to negative 4. So here I have y prime times 2y minus 1 is equal to negative 4. Again, keeping in mind I'm trying to solve for y prime, my last step then is just to divide by this 2y minus 1. So I should end up with y prime equals negative 4 divided by 2y minus 1. Here is my derivative. Now, one thing that you'll notice that is a little bit different about our derivatives that we'll find using implicit differentiation is they may be in terms of both x and y. So you may have a derivative that is only in terms of x, like we did in the last example. Here, we actually have something which is only in terms of y. And then there may be some cases where we have a derivative that is in terms of both x and y. So that means that if I wanted to evaluate the derivative at a certain point, I'm generally going to need an ordered pair. I'm going to need an x value and I'm going to need a y value here. And we'll look at some examples like that later on towards the end of this section. But just if you have a y in your derivative, that doesn't necessarily mean it's going to be wrong in this chapter, because we will have that occur from time to time.